called as de Moivres theorem. Okay, this is associated with the complex numbers and its representation. So we have various types of statements of de Moivre's theorem, right? All are leading to the various types of applications. Okay, so the first statement is like this. So if theta 1, theta 2, theta 3, dot, up to say theta n, different values of arguments are present and every argument is real, and let's define I, which is equal to root of -1, then so you take a product, that is cos theta 1 plus I times sin theta 1. I know this is a complex representation, polar format, into cos theta 2 plus I sin theta 2 into cos of theta 3 plus I into sin theta 3 dot, all the products, all the terms very similar to this. This is cos theta n plus I sin theta n, right? This is the left hand side. This is nothing but this can be replaced by simply cos of theta 1, theta 2 plus theta 3, theta n plus I sin times same thing, theta 1, theta 2, dot plus theta n. Okay, we can write in the following fashion. Statement number 1. Okay, very similarly, let's go to the statement number 2 now. This is if a theta belongs to real numbers, n belongs to integers, and I is equal to root of -1, then we can write cos theta plus I sin theta whole raised to the power n. This is nothing but same term being multiplied n times, cos theta plus I sin theta into cos theta plus I sin theta into dot up to n times, right? This should be equal to, right? We apply the above rule to get this, right? So theta 1 ನಾನು n times add ಮಾಡಬೇಕು. So theta plus theta dot, it's n times, it is n theta. So this can be written as cos n theta plus I sin n theta. Okay, so the function becomes in the following into the following notation, right? Cos theta plus I sine theta to the power n is equal to cos n theta plus I sine n theta. Okay, so there is I into sine n theta. All right, then the third type of statement is like this. Okay. Statement number 3 is if theta is equal to r, theta belongs to r, theta is real number, and let's write n belongs to q, right? Q is actually set of rational numbers, right? Anything in the order, say 2 by 3, 8 by 9, right, etc. are the rational numbers. If you have any rational number, and also I need to define, and I is equal to root of minus 1. Okay, if this is a condition, then this is also going to generate cos theta plus I sine theta whole raised to the power n is equal to cos n theta plus I times sine n theta. The same equation which we have written earlier holds good for this. Okay, this particular theorem itself is considered as the de Moivres theorem. Okay, now let's try to write the other forms of other other forms of de Moivres theorem. Right. So the first form which we use in many problems are like this. Let's say I write cos theta. What if there is a minus form here? So this is minus I sine theta, and let's say we want to raise this to the power n. So this is nothing but this should be always equal to cos n theta minus I into sine n theta. So ಅಲ್ಲಿ ಒಳಗಡೆ minus ಬಂದ್ರೆ this is cos theta minus I sine theta to the power n. We are going to write it as cos n theta minus I sine n theta. Okay, then there is another form that's also very useful. If you have cos theta plus I sine theta to the power n. Okay, this is cos theta plus I sine theta to the power n can also be written as this is I to the power n into I to the n into this is cos n theta minus I sine n theta. So normally cos theta plus I sin theta to the power n is cos n theta plus I sin n theta. This is the alternative option. Okay, that is to write I to the power n cos n theta minus I sin n theta. Okay, that's the second alternative format of this. Then let's go to the third one. This is if we try to write sine theta minus I times cos theta to the power n. This is always equal to. Now you see this is minus I to the power n into cos n theta plus I sin n theta. Okay, this is actually sin theta minus cos theta to the power n can be substituted as this. Then we have the fourth format, that is cos theta plus I times sin phi. It's a different angle. Okay, to the power n. Now you cannot equate. This is not equal to, just remember, not equal to cos n theta plus I sin n times phi. They are not equal. Okay, then the other important form is nothing but 1 divided by cos theta plus I sin theta is nothing but, this can also be written as cos theta plus I sin theta to the power minus 1, right? Whenever I have a power minus 1, I know that I can actually make the following substitution. This is equal to, now cos, right, n theta, n is minus 1, so minus theta, then this is plus I times sine minus theta. Correct. So we put minus theta over there because power is minus 1. Right? We know that for any integer n, this is valid. So this is now equals to, right, cos of minus theta is cos theta, and sine of minus theta is minus sine theta. So minus I sine theta. Okay, so cos theta minus I times sine theta is the required format of 1 divided by cos theta plus I sine theta. Okay, now let's go to the first problem based on this concept. If ZR is equal to cos pi by 3 to the power r plus I into sine of pi by 3 to the r. Find the value of z1 into z2 into z3 into dot 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 up to infinity. So take a product z1, z2, z3, z4 dot 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 up to infinite, right? All the infinite terms. If you take a product, what is the answer is what they have asked. Okay, now let's write a zr. Z1 anta bandre r value 1 hakondre, so that is z1 cos pi by 3 plus I sin pi by 3. Then z2 is nothing but cos pi by 3 square plus I sin pi by 3 square. Correct. Okay, like that we have every term needs to be substituted here, right? Let's try to write what we require. So this implies, so the required term is z1 into z2 into say z3 z1 into z2 into z3 up to infinite terms should be equal to z2 into z3 into okay, it's not right to z term, so into dot 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 dot, this is up to infinity dot 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 to infinity z2 into z3, okay, is equal to, now let's write this is equal to, let's write the z1. Z1 is nothing but cos pi by 3 plus I sin pi by 3, first term. Second term, z2 is cos pi by 3 to the r, so r is 2, pi by 3 square plus I sin, this is pi by 3 square into the next term, right? The next term should be, first of the Moivre term burdre sakal. Then we understand what we are going to do. Okay, because there are infinite terms. So into cos pi by 3 cube plus I sin pi by 3 cube dot 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 pi by 3 cube dot 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 to infinity. Okay, now I know that the terms are uh, cos theta 1 plus I sin theta 1 into cos theta 2 I sin theta 2 and so on. We know that by applying the Moivres theorem, I can write this is equal to cos of sum of every theta, that is pi by 3 plus pi by 3 square, correct, plus pi by 3 cube plus dot 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 to infinity pi by 3 square pi by 3 cube to infinity. This is the first term plus I times sine of infinity. Okay, so plus I times sine of, once again same thing, pi by 3 plus pi by 3 square plus you write pi by 3 cube plus dot 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 till infinity. Okay, now I have to apply a formula, right? It's actually from infinite series, right? Whenever you have, see, this is an infinite series, pi by 3, pi by 3 square, pi by 3 cube, and so on, right? This can be written in the following fashion. So whenever I have the terms like this, the term inside the bracket can be written using simplification of the infinite series like this. This is equal to pi by 3, which is the first term of your infinite series, divided by 1 minus what is what is the common ratio between every number in the sense pi by this, pi by 3 square and pi by 3. Is there any common thing compared to the pi by 3 cube by pi by 3 square? So that is 1 by 3 ಅನ್ನೋದು common ಇದೆ. For example, take pi by 3 square divided by pi by 3. You see pi cancels and the 3 square cancels with 3. So you are left with 1 by 3. That is a common ratio. So that is 1 by 3. Then plus I into sine of, since the infinite series still remains same, you can write this as pi by 3 divided by 1 minus pi by 3. Okay, so this is a simplification of the infinite series. So that means this is equal to cos of, so pi by 3, 1 minus pi by 3 is nothing but, let's simplify. This is cos of, numerator is pi by 3, denominator is 3 minus 1, that is 2 by 3, plus this is also I into sine of pi by 3 divided by 2 by 3. So illu 3 cancel agutte. So you are left with the pi by 2. So this is equal to cos pi by 2 plus I times sine pi by 2. So cos 90 is 0. This is equal to cos 90, pi by 2 is 0. So sorry, pi by 2 is 90 degrees. Cos pi by 2 is 0 plus I times sine pi by 2 is 1. So the final required answer is equal to I. So find the product in the question banditala. That means this is the answer. All right. Then let's move to the next question. This is Z is equal to cos theta plus I sine theta cos theta plus I sine theta to the power 4 divided by cos theta. This is plus, okay, cos theta cos theta plus I sine theta to the power 4 whole divided by, this is okay, sine theta plus I cos theta to the power 5. Okay, numerator is power 4, denominator is power 5. In Okay, let's not write that issue. In P plus IQ form, in P plus IQ form, right? So which means reduce the fraction into some simple way. Okay, that's the question. That is right. So this is equal to, so numerator let's write as it is. This is cos theta plus I sin theta to the power 4. Denominator, see, sin theta plus I cos theta, right? So sin theta plus I cos theta, can you write it in this format? This is equal to, refer the alternative forms. Other forms ಅಂತ ನಾವು ಬರ್ದಿರಲ್ಲ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So we are going to use the other forms over here for the reduction purpose. Okay, for reducing the given term into the required standard format, because only when you have cos theta plus I sin theta in the denominator I can simplify. Okay, but now I don't see that there is a cos theta plus I sin theta, because denominator has sin theta plus cos. So since the sin plus cos form is available in the denominator, somehow I need to convert that into the cos plus sin format. So for that reason, now we are going to use the other forms of de Moivre's theorem which we have written already. Okay, so this is, if you have sin theta plus cos theta, that can be reduced like this. Okay, so this is equal to, right? Okay, sin theta plus I cos theta to the power n can be written as I to the power n, right? You can definitely write this as I to the n cos theta minus I sin theta. Okay, so that can be written like this. So this is equal to, I write I to the power n is 5, I to the 5 into, this is cos theta minus I sin theta to the power 5. Okay, but still they are not same. I cannot club them. So for that reason, I'll once again write cos theta plus I sin theta to the power 4 whole divided by I to the power 5 is what? I square, I cube, I to the 4 is going to be same as I to the 0. Then I to the 5 is equal to simply I. Right? We know the property of I. So using that I am writing this. So I to the 5 is simply I. Okay. Now cos theta minus I sin theta can be written as, this is cos theta plus I sin theta to the power minus 5. So now you see the numerator and denominator are in the same format. I can club them. So this is cos theta plus I sin theta, okay, to the power, there is a 4 in the numerator and denominator has a minus 5. When you take the denominator minus 5 to the numerator, this becomes plus 5. Okay, so there is already 4. 4 plus 5, the power becomes equal to 9. Okay, so this is cos theta plus I sin theta to the power 9 divided by, there is a I. Okay, so when you divide by I, 1 by I is minus I. So I get minus I into cos theta, and I cancels. So plus sine theta to the power 9. Okay, so this is equal to sine 9 theta minus I cos 9 theta. So you are getting this answer in the P plus IQ format. Okay, similar question to solve now. So this is simplify cos theta plus I sin theta to the power 8 divided by, this is sin theta plus I cos theta to the power 4. Yes, this is right. Next question is ತೊಂದರೆ ಇಲ್ಲ, ಡಿನಾಮಿನೇಟರ್ 1 ಇರ್ಬೋದು. Okay, no problem. Now cos theta minus I sin theta to the power minus 4 divided by okay, this is sin theta plus divided by, this is sin theta plus I cos theta to the power minus 6. Very similar approach. ಆಯ್ತಾ, solve ಮಾಡೋಣ. This is equal to cos okay, sine of 10 theta. Okay, sine 10 theta minus 10 theta minus I cos 10 theta. All right. Okay, next question. Cos theta plus I sin theta to the power 6 divided by sin theta plus I cos theta power 4. Sine 10 theta, okay, minus